Hello everyone, this is Mayank Bhatt from IT department of Acropolis Institute of Technology and Research, Indore. Today I am going to deliver you a lecture on the topic Introduction of Data Structure, which comes under Data Structures and Algorithm. So here we begin. So first we have to learn about the introduction of data structure. In that, first is what is a computer. So as you see, computer is an electronics machine or device which is used for storing and processing data, typically in binary form. A particular which we can say a diagram has been given here in this PPT, in which basically there are three we can say three different devices are there. First is input devices, then second is the central processing unit, and the third is the output devices. Now when we give input, then in the central processing unit there are some control units and arithmetic logic units, which will be helped by the memory unit, so that the data can be saved or retrieved from the memory. And after the processing, after the execution, it produces an output which will be displayed outside the output devices. uh, some more examples are there, that the computer has limited memory, so there is a need for efficient utilization of memory. Now the computer memory is divided into the smallest unit called bits, and memory has some addresses. Computer stores and manipulate large amount of data. The type of data and storage of data are very important. Here we can see, when we talk about memory, so how we can use those memory. So memory can be used in two different forms. The first one is the primary memory, and the second one is the secondary memory. Now the primary memories are those memories which are directly used by the processor during the processing time or execution time, and the secondary memory are those memories which can be mapped, or which can be used to retrieve data into the primary memory. So that is the focus on memory. Further, now the question arises that what is the data. So data is a collection of facts such as numbers, words, measurements, observations, or just descriptions of things, unorganized data. Now what is information? So organized or classified data, processed data, these all are called information. So you can see that there are lots of data available in the figure. You can see there are different data we have. Now after processing those data and organize those data accordingly, that the combination of all these, the number of data, is simply termed as a information, which is useful, which is organized, which is classified. So that is the information and difference between the data and information. Sometimes there are many people says that data is information, data is a message. So these all comes, but the exact meaning of information is that we have a data, and the data will be processed, and this, after the processing of this data, we find the information. So there are some more description about what is data structure. So data structure may be defined as the logical or mathematical model of the organization of data elements in the computer memory. Some specific method exists to access and process the data elements in the computer memory. This specific method is called an algorithm. The mathematical model to organize the data in the computer memory and the methods to process them are collectively called data structure. Now data structures are the basic building blocks of the program. Therefore, they should efficiently process the elements. So, what is the major focus here? So, once we have a problem, then after applying logic to those problem and find a particular solution, we have to design some data structure so that the problem's solution can be stored on those data structures. And after that, that problem, that steps which we have used to receive the outputs, correct solution of that problem will be in future will be organized in an algorithm or bind in an algorithm. So here the classification of data structure you can see. So data structures are basically we can say having two forms. One is built-in data structures, and the second one which user can define, or we can say user defined data structures. Now built-in data structures, we have already seen that integers, floats, characters, pointers, these are the built-in data structures which is already available in any type of programming languages. Now the second one, we can see that there is a user defined data structures. Now the user defined data structures are basically you can see there are certain availability are there. Now in that you can see array, or we can see there are two types of user defined data structures. One is linear data structure and other one is the non-linear data structures. Now the linear data structure comes under array. Now comes in under the linear data structures, array, stack, queue, linked list, these all under the linear data structure, in such a way that a particular element is stored just after that previous element. So there is a linear way, there is a sequential form, there is a sequence will be formed there. So whenever there is a sequence formed, then that type of data structures is called linear data structures. Now the second one is the non-linear data structures. Now non-linear data structures are simply we can call as trees and graphs. So we can see that we in the tree we use a hierarchical model. When there is a parent, after that there are certain childs and so on. So the data will not be in a sequence, the data will not be stored in a sequence in the memory. So that is the basic difference between linear and non-linear. And the other things are that we can store these our data in a file structure manner. So file structures are already there. So we can see the basic example of that file structure is the OS and hard disk, which we are using C drive, E drive, like that. Moving towards the next slide. Now the definitions of these types of user defined data structures are, now the first one is the array. So array says that it is a collection of same or similar type of data. So if let's suppose we are using integers, so array only stores integer values. Okay, so array is a collection of same type of data items and stored at contiguous memory locations. Now second is the stack. A stack is a container of items that are inserted and removed according to the last in first out principle. So what is the basic concept of that? Once we insert an element inside the stack, then that after that again the next element we have inserted in the stack. So what happens here, if we want to remove an element, then what the element which is stored in the last place, or the element which is stored at the last place, then that last element will be first taken out. So that is called last in first out principle. Now the queue, now what say queue is? A queue is also a container of items that are stored or removed according to the first in first out principle. Just like any, you can see any ticking, like ticking booking system, when there is a queue, like bank there is a queue, first whoever person reach at particular place, then the next person comes behind that person, so there is a queue. So queue will be entertained that the first person which come and stand on that position, that position will define that at which position he will be entertained. So at first position, if you have standing there, then he will be entertained first. At the second position, there is some person standing there, then second person will be entertained at the second position. So this is the first in first out concept. Now the third is the fourth is the linked list. A linked list is a collection of nodes where each node is connected to the next node through a pointer. So if you say array, in array there is a sequence. The structure is sequence panel. If we store the 10 elements, then all the 10 elements are stored in a sequence. But when we using linked list, so linked list is just a it is the overcome of a drawback of array. And what is that drawback? So array has a drawback that if array has to whenever we use array, we have to declare that array, and if we declare the size of array like 10 and we use only 4 elements, then what happens? The rest 6 spaces will be blank and there is no use, so it will go waste. So to avoid that disadvantage, we use linked list. In such case, we use linked list, and we the memory allocation will be dynamically here, and whenever you inserted a new node, that for that new node memory will be allocated. So linked list is such concept, and this linked list is especially used in tree and graph. So what do we mean by tree? A tree can be defined as a collection of nodes starting at a root node, where each node is a data structure consisting of a value together with a list of references to node, that will be called as a children. Now the next is the graph. A graph is a pictorial representation of a set of objects where some pairs of objects are connected by links. So these are all the definitions. Now the data types, you can see there are some data types having different sizes in bytes. So integer data type having 2 bytes, character data type having 1 byte, float having 4 byte, then double, then 8 byte, then long int having 4 bytes. So these are the sizes in bytes. What are the common operations? So basically the common operations on data structures are, so first thing is the creating. The first operation used to define the data structure for the data elements is called create operation. This operation reserves the memory of the memory for the data element. Okay. Second one is the traversal. The elements of data structures are accessed in order to process them for various operations, and the accessing or visiting of each element of the data structure exactly once is called traversal operation. Third is the searching. The operation used to find the location of a particular element in the data structure is called search operation. Fourth is the insertion. The operation used to add some element into the data structure is called insertion operation. Next is the deletion. This operation used to delete the existing value of the data structure, so that operation is called deletion operation. Sorting. Now sorting is the uses by some application which required arranging the data elements in a specific order, like ascending or descending. So the arrangement is called sorting operation. Merging. In the merging operation, we generally use that particular operation for let's suppose we have two different sorted list or two different sorted array, and we want to combine those into a single sorted sorted list or array. Then at that moment we use as merging operation. And the last one is the updating operation. The operation used to change existing values of the data structure. So such a type of concept is called updation operation. So So that's all from my side. Thank you very much.